We're talking. Okay, we're going, so I just accidentally hit record. So, okay, lesson 59. Here we go. You're ready anyways, but okay. Lesson 59 is computing areas, more numerical integration on a graphing calculator. Area is our name of the game today. And actually, we're going to talk area today, and we're going to talk area Monday in lesson 60. We have talked a little bit, when we talk area, in terms of calculus. What's your brain supposed to connect with? Integral, right? The geometric definition of an integral is the area under the curve. Or in other words, the area under the curve between the curve and the x-axis. So, note here it says we have to first remember that the definite integral of a function is related to area. Now, I believe we talked at the time. Okay, so if I just stated this as the area under a curve. When I say area under a curve, I'm saying the area under the curve and above the x-axis. So the area between the curve and the x-axis. If that area is above the x-axis, it has a positive value. So this section is going to have a positive value, and this section has a positive value. Have we talked about what happens when the area is below the x-axis? I feel like we talked about it at one point a little bit. Yeah, okay. Yeah, we looked at the sine curve and the idea of if you actually just work the integral from 0 to 2 pi, you're going to get 0 because the sine curve above and below the axis is equal from 0 to 2 pi. Okay, I remember that example now. So the idea that anytime you have a curve or a portion of the curve underneath the x-axis, it has a negative value. And the idea here is it's because it's below the x-axis, it's kind of like the x-axis minus the curve. Okay, what this means is if they specifically want area, okay, if your job is to specifically find area, you can't just say, oh, area, integral, set up your integral and go. You have to consider the graph, and if there are sections that are below the x-axis, they have to be subtracted instead of added to compensate for that negative. Okay? So, speaking of sine, we get to talk about this as our first example. Find the area between the graph of y equals sine x and the x-axis between x equals 0 and x equals 2 pi. Notice, it says find the area. It's not asking us to find the value of the integral, it's asking us for area. So, we let ourselves right into this because we've already talked about this. Between 0 and 2 pi. Okay, what do you guys know about the sine curve? Okay. There's my attempt at a sine curve. Starts at 0, 0. It goes up. It cuts back through at pi. It goes down. And then it crosses the x-axis again at 2 pi, yes? So when it says to find the area between sine x and x-axis, that means we're trying to find this area above the x-axis and this area below the x-axis. The area above the x-axis, when we do the math, is going to work out positive. What about the area below the x-axis? It's going to work out negative. So if we just do these two integrals, or if we just do the integral from 0 to 2 pi, we talked, they're going to cancel each other out. If we break it up and we do these two integrals and we add them, we're going to be adding a positive value and a negative value that are still going to cancel each other out. So the workaround is instead of adding these, anytime it's a negative, it's going to have a negative value, we turn around and subtract it. Because if you then subtract a negative, in turn you are adding. Okay? So, when it says find the area between 0 and 2 pi, yes, officially, we are doing the integral of sine x dx from 0 to 2 pi. The key is we just can't work it like that. So we have to break it up into our sections based on what our graph looks like. So this is where you have to graph them today to figure this out. So our first section is going to be from 0 to pi of sine x dx. That will work out to be a positive value because it's above the x-axis. What about our section from pi to 2 pi? Yeah, because it is below the x-axis, I know it will have a negative value. So in order to get that value to actually add to the first one, we're going to subtract it. So we're going to subtract the integral from pi to 2 pi of sine x dx. Good news is you're integrating the same thing twice. So it's not like you have to do different integrals here. Okay, this is a do-it-by-hand type of problem. What is the integral of sine x? Yep, negative cosine x. So on this first one, we're going to do the integral of negative cosine x evaluated between 0 and pi. Minus, well, the integral of sine x again is negative cosine x. This time it will be evaluated from pi to 2 pi. Okay, so this means, how do we do this? Negative cosine x evaluated from 0 to pi. What's fundamental theorem of calculus say here?
Negative cosine of 0 minus negative cosine pi.
Reverse. Higher boundary minus upper boundary minus lower boundary. So it's going to be negative cosine of pi minus negative cosine of, start to write theta instead of 0. That's a 0. Okay? And then we're going to subtract. And then this time we're doing negative cosine of 2 pi minus negative cosine of pi. It's a lot of signs there to keep track of, so be careful. Okay, cosine values. Do you guys like looking at the graph or the unit circle? Should I take a moment to review this? I'm sorry, what did you say?
On the unit circle, I generally just go on the unit circle for the 4 points.
Okay, if you go off the unit circle for this one. I mean, options include, and I don't care, you know, if we go off the unit circle here, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? This ordered pair is 1, 0. Ordered pair when you go up is 0, 1. When we go left, it is negative 1, 0. When we go down, 0, negative 1. Yes? Which values are my cosine values? The x's, right? Because it's cosine, sine. That's option 1, yes? I'll be honest, I don't care which option you use. I'm just doing a reminder to use. Here's the other option. Your cosine graph. Are you comfortable with your cosine graph? Here's my cosine graph, yes? So it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. This value up here is 1. This value down here is negative 1. So there is the other way to figure it out. In that the cosine at 0 is 1. The cosine at pi over 2 is 0. Cosine at pi is negative 1. Cosine at 3 pi over 2 is 0. And cosine at 2 pi is 1. 1, 0, negative 1, 0, 1. What works better for your brain, right? Okay. All of that to say, okay. Negative cosine of pi. Positive 1. Minus negative. So plus. Cosine of 0. 1. And if you will, 1 plus 1 is 2. Minus, okay, other set of parentheses, negative cosine of 2 pi. Negative 1. Minus negative, so I'm automatically going to say plus there. Cosine of pi. Negative 1. Negative 1 plus negative 1, the way I have this set up is negative 2. I now have 2 minus negative 2, which is 4. For what? It's area, so officially we can say units squared. Obviously, you may have worked the actual math out slightly different than me along the way with the, how you did your signs and all of that, but here's the key. Did we all come out at 4? Okay? If you worked ahead of me and worked, your signs differently, I get it. Okay. Now, I do have one other thought there. In this particular problem, what is another way I could have done this? Okay. Because these are symmetric portions. I realize my graph does not look exactly symmetrical, but you know in your brain they are symmetrical. Okay, because this mountain and this valley are symmetrical, you could have legitimately done 2 times the integral from 0 to pi of sine x dx. That is definitely a legitimate direction to go. Is it a shortcut? It might be quicker if you see it, okay? When we start looking at AP questions and I look at my AP answer key, that's something they will tend to do, is they would double it instead of subtracting the other one, if they're symmetrical. Okay? Ready for example 2? Okay, find the area of the region bounded by the graph of y equals x squared minus 1 and the x-axis over the interval negative 2 to 2. What am I going to suggest? Draw a graph. And trust me, you need a picture in this one because there's, some things to take into account. So, okay, what do you know about this graph?
It goes out 2 each direction on the x-axis.
Okay.
On the y-axis, it goes from 3 to -4.
Okay. when we talk about y equals x squared minus 1, you guys know that that is a parabola moved down 1, correct? And so, if I take my parabola and I move it down 1, think with me, what do we know about the initial points on a basic parabola from x? Sorry, it glitched for a moment. From that vertex, which is down 1, my first set of points go over 1, up 1. So those are going to be at 1 and negative 1 on the axis, right? My next set of points from the vertex go 2, 4, over 2, up 4, which puts me at 2, 3, and negative 2, 3. Does that make sense? So there's my parabola. The directions asked me for the area of the region bounded by the graph and the x-axis over the interval negative 2 to 2. So that means as we look at this, we're going from negative 2 to positive 2. So from dotted line to dotted line. Okay, what does that look like? Where is, so the area of the region bounded by that parabola and the x-axis? So where it has the x-axis on one side, the parabola on the other side. What sections do we have to consider here? Okay, so from negative 2 to 1, what am I looking at? This little, not exactly triangle, but triangle-ish shape. And from 1 to 2, we also have a triangle-ish shape. And then we also have, so that's my sections that are above, because that's where my parabola is above the x-axis. Here my parabola is below the x-axis, so we have to consider what Daryl referred to as the bowl. So we have to refer to that section down there. What do you know about the two sections above the x-axis? They're going to have what kind of value? Positive values. What do we know about the section below the x-axis? It's going to have a negative value. So when I set up my integrals, I have to account for that, right? That didn't catch. Okay. And we're doing this because the directions did say find the area. Not just find the value of the integral, but find the area. So, the original integral in my brain is from negative 2 to 2 of x squared minus 1 dx. But if we do that as is, we won't get the right answer. Because we'll have the two positive sections and the math will automatically subtract the section below. So, we're going to break this up into how many sections? 3 effectively. The first section goes from, if I go just left to right, negative 2 to negative 1 of x squared minus 1 dx. Then what's the next section? Yeah, the bowl, so to speak, is negative 1 to positive 1 of x squared minus 1 dx. What do I know about that bowl? What do I need to do with this integral? Subtract it. Because that bowl is underneath the x-axis, has a negative value, we're subtracting it. And then what? third section is the integral from 1 to 2 of x squared minus 1 dx. Are we adding or subtracting this section? Adding, because it is above the x-axis. Okay. If you wanted to, what could you do? Okay. This first integral and this second integral are the same, correct? Based on what we know about the symmetric qualities of parabolas, we know that those two regions would be equivalent. So you could do 2 times one of them. If you did that one, which one would you prefer to do? One to 2, because you get to use positive x values. That would be the advantage there. So I'm going to rewrite this so that instead of having 3 integrals, we're going to have 2 integrals. We're going to have 2 times the integral from 1 to 2 of x squared minus 1 dx. And then we still have to subtract the other integral from negative 1 to 1 of x squared minus 1 dx. Do you have to do it that way? Of course not. Okay. Don't forget the 2 out front of this first integral. What is the integral of x squared?
X squared. 1/3 x squared. Well, that was confusing me too. Wait a minute.
Okay, so common mistake. Nathan went derivative first. We actually need to go integral, right? So go up powers with integrals. So 1/3 x cubed minus, what's the integral of 1? X. Okay. Nathan's getting all the derivatives out of the way for us. Okay, and this will be evaluated from 1 to 2. Minus, good news is, you get a redo. What's the integral of x squared? This should be the easy time. 1/3 x cubed minus x again. This time it'll evaluate from negative 1 to 1. Okay, do your math, don't make any mistakes, right?
Oh, yeah, that's kind of all plastic.
Okay, with this one right here, I'm going to say 2 times the quantity. Okay, first time through, we have to punch in 2. 1/3 times 2 cubed is going to be 8/3 minus 2. And then, oops. So I've got 2 out front. Then I've got a bracket. Then in parentheses, what I get when I put in 2, which is 8/3 minus 2, minus, now I'm going to do a second set of parentheses, what I get when I put in 1. When I put in 1, it's going to be 1/3 minus 1. In the parentheses, in the bracket. Minus. I'm going to do a bracket this time. First time we're putting in 1. So when I put in 1, it's going to be 1/3 minus 1 in that parenthesis, minus, and now I'm putting in negative 1. Negative 1/3 plus 1 in parentheses, in bracket. I wrote a little bigger than I should have because I should have room for another line of work, and I don't. Yikes. What did I do differently? Okay. Trying to decide what the best way to do this is. And this is one of those things, should you be trying to do this without a calculator? Well, you don't want me to say it, but there's an advantage to doing this without a calculator. There really is. Well, in terms of knowing how to do it. So I know if I work within this first set of brackets right here, I see an 8/3. I'm going to be, if I worry about the thirds here, I'm going to be subtracting, or do you guys want to do this all in thirds? Might be easiest to do it all in thirds, huh? 8/3 minus 2, well 2 is 6/3. 8/3 minus 6/3 is 2/3. Hold that thought. Over here, 1/3 minus 1, negative 2/3. So 2/3 minus negative 2/3, 4/3. And we have that 2 out front because we were doubling the integral. So 4/3 times 2 is going to be 8/3. That wasn't as horrible as I thought it would be. Or maybe it's just because you guys can actually do fractions. I'm sorry, it's the truth. It's the truth because I get some years that you guys, I don't know, for the most part you guys seem to follow along just fine with that. I get some years where it's not the case, so.
She's thinking herself, man, these guys are not going to get this. All right.
No, I'm impressed. You guys did get it. They don't always get this. Okay. 1/3 minus 1. Negative 2/3. Negative 1/3 plus 1. Positive 2/3. Negative 2/3 minus 2/3. Negative 4/3. But it's minus negative 4/3, which is going to make it plus 4/3. And 8/3 plus 4/3.
7/3.
Not even responding. I wrote 12 units squared. Why did I write 12 units squared? Logan, you're not helping me
Oh, I
here.
thought that was an actual question. I thought she was like, "No, you guys know why I wrote this." I was like, I have no idea. That's not what I got.
It's 12 over 3, which reduces to 4. It's called I made a mistake and I combined steps. 4 units squared. I quit. Okay. We still have 2 more problems to go, folks. We messed around way too much at the beginning of class today. Moving along. Sample 3. Find the area of the region completely enclosed by the graph of y equals negative x cubed minus x squared plus 2x and the x-axis. So, do you know what that graph looks like? So if you don't know what it looks like, what do you do? Graph it on the calculator. Now, do you notice what's the highest power? X cubed, negative x cubed. So a typical x cubed, what? Starts low and goes high. This one's going to have to high, end low. You can find your x-intercepts. We factor this, negative x cubed minus x squared plus 2x. I could factor out GCF of negative x, which leaves me with negative x carries down. This is going to magically factor into x and x, 1 and 2, plus 2 minus 1. Do you see where I'm going with this? Set each factor equal to 0. What are my zeros? 0, 1, and negative 2. So my zeros means these are my x-intercepts. So even though I just said graph it on the calculator, is this what your calculator is showing you?
Yeah.
You have x-intercepts at negative 2, 0, and 1.
Is there a way we can make the calculator find the area of the selected region?
To my knowledge, no. Now, you can do integrals on your calculator, but you'd still have to compensate for positives and negatives. Okay. Find the area of the region enclosed by this graph in the x-axis. So what are we looking at here?
Between negative 2 and 0 and 0 and 1.
Okay. We have a bowl and an upside down bowl, if you would. So when we set this up, officially, we're doing the integral from negative 2 to 1 of negative x cubed minus x squared plus 2x dx. But we need to break this up into our two pieces. What do you know about those two pieces? The bowl is going to have a negative value. The upside down bowl is going to have a positive value. So, since we usually go in order, what does that mean I need to do with the integral from negative 2 to 0? Yeah. Basically, put a negative out front. So I'm going to say the negative integral, or like Daryl said, negative 1, from negative 2 to 0, of negative x cubed minus x squared plus 2x dx. And then if I go in that order, what about the integral from 0 to 1? You're going to add it. So adding 0 to 1 of negative x cubed minus x squared plus 2x dx. Could you reverse those if you prefer? Most definitely, right? If you'd rather have integral minus the other integral, you can do that. Okay. My first one's going to have a negative out front. Okay, guys, you get to practice your integrals again. Let's see if we can do better this time. You know what? He did not have a lot of support at the beginning. It took you guys a while to catch up and, correct him from his errors. So I'm not just throwing Nathan under the bus on this. He was the one that vocalized answers. It took a while for the rest of you to correct them. Okay, integral of negative x cubed.
Negative 4x. Negative 1/4 x to the 4th.
Okay. Negative 1/4 x to the 4th minus integral of x squared.
Negative 1/3 x to the 3rd.
Minus 1/3 x to the 3rd. Plus integral of 2x.
1/2 x.
Just x squared because there's already a 2 out front.
You got one of them, right?
Again, I didn't see anyone else.
I said x squared.
I mean, I see you guys helping him correct him after he makes the mistake, but I don't see anyone else volunteering answers.
I was giving him a chance.
Okay, so that one's going to be evaluated from negative 2 to 0. We're going to do the same thing over here, negative 1/4 x to the 4th minus 1/3 x cubed plus x squared evaluated from 0 to 1.
I integrated the sine equation.
Huh?
Example 1, I integrated the trigonometric equation.
He did say negative cosine.
There you go.
Okay. You guys are something else here. Dang it, we've taken too long. Okay. Just means you have to do it without me.
Okay. All right, Nathan, have you?
Oh my god.
Okay. I've got the negative out front, and then I've got a bracket. What's the value I'm putting in first?
0.
0 because it is the upper boundary. We're doing 0 is my upper boundary. So when I put in 0, we're going to have 0 minus 0 plus 0 in my first parenthesis. And then fundamental theorem of calculus says we subtract, and now we're putting in negative 2. Now you have to math. Okay, negative 2. When I put in into negative 1/4 x to the 4th. 2 to the 4th is going to be 16 divided by 4. Divided by the negative 4, I guess I should say, is negative 4. Okay. Now putting in negative 2. Negative 2 to the 3rd is negative 8. And the minus 1/3 is going to make this plus 8/3. And it's plus x squared, so plus 4. Okay, plus. Now, this time, what do we put in first? 1. When we put in 1, what am I going to get with my 1s? Okay, negative 1/4 minus 1/3 plus 1. And then minus, and what do we put in next? 0. And we really like that because it all turns out to be zeros. And you could just write 1 0 there, not even write anything, but okay. What do you notice about this first set? Okay, within the parentheses, our 4's cancel. So right here we have 8/3.
0 minus 8/3 is negative 8/3. It's negative that. So it's plus 8/3.
I agree.
There's too many negative signs.
There are, which is why I was letting you go. Okay, so yeah, it was 8/3 within the parenthesis, but it's 0 minus 8/3, which makes it negative 8/3. But then there was this negative out front, which made it positive 8/3. Oof, okay. Negative 1/4 minus 1/3 plus 1. Let's talk twelfths. So negative 3/12 minus 4/12 plus 1, so plus 12/12.
What did you say? Okay.
Let's go back to the beginning. Negative 1/4 minus 1/3. Negative 4/12, negative 3/12 minus 4/12.
It's negative.
Plus 11/12.
No.
I am totally disagreeing with 11/12.
If it wasn't negative,
I like 5/12 because it's negative 3/12 minus 4/12, which is going to be minus 7/12, plus 12/12, which makes it 5/12. I'd say you guys are obviously missing some sign up there.
I missed it before the 1/4.
Okay. 8/3 plus 5/12.
29/12.
did you say?
29/12.
Not what I have.
It's not that.
37/12.
Multiply the first fraction by 4.
Yeah,
4 times 8 is 32/12 plus 5/12.
Why did I think 4 times 8 was 16?
37/12 units squared. Oof.
You can do it.
Man, we are testing these math skills on this Friday.
Well, by the time we get to the bottom of that page with all those fractions, we were doing pretty good till the last problem.
Okay, one more, guys. Got 8 minutes. Yes, you need your calcs on this one. Notice on the others, I haven't picked up a calculator. I've been able to do all these calculations, everything, without a calculator. This one, we can use the calculator to find areas, definite integrals on the graphing calculator. Simply be careful of graphs that lie both above and below the x-axis. Using a graphing calculator, approximate the area of the region completely enclosed by the graph y equals x cubed minus 7x squared plus 2x plus 5 in the x-axis. Well, this one is not factoring. This one I am not graphing by hand for multiple reasons. So let me get this parabola off here and graph x cubed minus 7x squared plus 2x plus 5. Okay, I can see what I need to see here. I mean, we knew it was a cubic, so there was no question there. I can see that my graph goes zoom, zoom, zoom. Okay. Like all those whoop, whoop, whoop. Now, what do we need to know? The intercepts. How do we find said intercepts? Yeah, you have to find your zeros. Second calc or trace, 0. Left bound, right bound, guess. Notice, are they nice, neat whole numbers? Nope. I'm going to go 4 decimal places. Negative 0.6868 on the first one. Second calc 0. Are you guys doing this with me or am I doing this by myself? Okay. 1.1062. Oh man, that guy goes way down there. 6.5806. And thus, this problem is impossible to do without a calculator. Okay. What do we know about the area here?
The first interval is positive, the second interval is negative.
Okay. First interval is above the x-axis and thus has a positive value. Second interval is below the x-axis and thus has a negative value. So we're going to write this out. The first interval goes from negative 0.6868 to 1.1062. And that's going to be of x cubed minus 7x squared plus 2x plus 5 dx. And what am I doing with the second interval? Subtracting. And it's from 1.1062 to 6.5806 of x cubed minus 7x squared plus 2x plus 5 dx. What's the good news?
You can use y1 instead of writing all that out.
When you put in the integral?
Yeah,
Is that what you're talking about?
I think so.
You know, you might be able to. Interesting thought. Not what I was going to do, but okay. So overall, my point is these are not friendly decimals. Can we just do the whole problem on the calculator at this point? So, oops. Math, what is it, number 9?
Yes.
Right? So I'm going to have to type in my boundaries. Negative 0.6868, 1.1062. Now, this is where I was going to type in the equation. Daryl, did you put a y1 in here and did it work?
I put y. Let me put y1. I don't know if I got the right answer, but let me put y1.
So up here somewhere, if I do, it would have been alpha f4. There's a y1. It's still going to be dx because it's in terms of dx, right? And then I'm going to, and you can go ahead, can you go ahead and type in the second integral?
Right.
Okay, and that's what I would do is minus another math 9. So this time it's from 1.1062 to 6.5806. Alpha f4 brings up y1 dx, and it gave you an answer. It's probably okay. Yep. Now,
I did something wrong. It said error.
that's a problem. What's the error message say?
Invalid.
That doesn't help me with what's invalid, but
Put in
okay.
the right attempted to use a variable or function where it is not valid.
Do you still have your equation typed in to y1? That's what I'm trying to say. Okay, and obviously, I was just trying the whole y1 thing because Daryl suggested it. Obviously, you can type it in terms of x's, right? Yeah, you still have to have it in y1. The reason that worked is because we still had it in y1.
I thought I did, but
This makes me look really smart.
Yeah,
It makes me look smart for just being able to use it.
Exactly, yeah.
you didn't have to retype that at least. Yeah. Okay. Okay, guys, I guess we will double up on homework Monday.
triple for me.
Do you want me to look at your 57 real quick before you leave?
Probably.
I can get that 0 out of the grade book at least.